Today we'll look at how we can automate finite element model creation with template parts and selection recipes. Here we're picking up from where we left off from a previous demonstration. And we're going to begin by assigning attributes to the geometry. We'll begin with ensuring on the selection bar that we're selecting solid bodies, and we'll select an attribute of disk and a value of 3. Next we'll change our selection to face, and we'll assign some attributes to some of the faces. The faces that we'll begin with are going to be the contact faces, where we defined surface-to-surface contact. Here, since we've selected multiple faces, we'll do a bulk edit for attributes. Here we'll give it a name of disk contact, and we'll give them all the same value of 1. Alright, next we'll assign some more attributes to our cyclic symmetry faces. We'll call this cyclic, and we'll give it a value of 1. And then we also need to assign a separate cyclic symmetry attribute to the other cyclic face. We'll give it the same name but a different value. Alright, next we'll put an attribute on our fixed face. We'll call it fixed and 1, value of 1. Now we'll do the same thing to our blade. We'll begin by selecting the solid body of the blade and giving it a value of 3. Then we'll go for the contact faces on the root. We'll do a bulk edit for attributes here. We'll call it blade contact. And give it a value of 1. Alright, so now we've completed our attribute specification that we need for changing our selections for meshing and all of the aspects of creating our finite element model from geometry to selection recipes. But before we do that, let's go ahead and save what's going to be our template FEM, our template finite element model, as a different name. We'll call it stage 3 disk blade template.fem or templatefem.fem. Alright, then we can also give a different name for our FEM, which we're not going to be turning into a template, although we could. And also our sim, which we are going to be turning into a template. We'll call that the same prefix of stage 3 disk blade template sim. Alright, so we'll begin by making our mesh not dependent upon geometry, which it is currently, but instead pointing to that selection recipe. So I'll go ahead and delete that mesh, and we'll create a new one with the same recipe, but this time pointing to our selection recipe. But first we need to create that selection recipe. So let's go ahead and create a new selection recipe. It'll be a strategy attribute. We'll call it disk 3, third stage disk. We'll look at the entire model for polygon body based on an attribute of disk and a value of, I agree to give it 3. So if I hit the tab, we'll be able to select the preview and see that that in fact is the correct attribute that was assigned before. So now that we have that selection recipe, we can create our mesh, but before we do that, we want this template FEM to be used not only for meshing the disk, but also the blade. That way we can reuse the same template FEM. So I'll assign an additional selection recipe for meshing the blade. And that of course has no entities in it because the blade is not in this FEM, but that's okay. So here we'll go ahead and create a selection, go ahead and create a mesh that points to our selection recipe disk 3. And we can define all the parameters that we want to capture in that mesh recipe. And let's go ahead and give this give the mesh collector a little bit better name, titanium, and we'll go ahead and give our mesh a better name of disk 3. Now we can also create an additional mesh which won't actually have any elements in it that will point to our blade selection recipe. Then we can define the element size and all the parameters and what collector we want it to go into. So here you can see the element count is 0, and we'll give it a name of blade 3. Alright, so that is our template FEM. Let's go and define our template sim. Here we have a number of entities that we've created to create our finite element model, our sim, for specifying cyclic symmetry, face contact, constraints, as well as, well actually the rotation we don't need any selection because that's a entire model rotation, but temperature we do need selection of those bodies. So beginning with our cyclic symmetry, you can see that we're looking at region 1 and 2 for our cyclic symmetry constraint. And region 1 and 2 point to geometry, faces that define those regions. And what we'd like to do is create a selection recipe that references those attributes that are assigned to those faces instead first. So here we'll create an attribute selection recipe that will be cyclic 1. It'll look at the entire model looking for polygon faces that have an attribute string of cyclic and a value of 1. If I hit the tab key, then we can preview and see our selection. I have to hit that tab key first though. Alright, so that looks good. Then we can rename that to cyclic 1. And also we'll deselect all geometry and then just select our selection recipe. So now our region 1, which we'll call cyclic 1, will now be pointing to that selection recipe instead of geometry. So now we'll create another selection recipe for cyclic 2 that will be looking for polygon faces with an attribute of cyclic and a value of 2. We'll hit the tab key and we can preview. That looks good. All right, and then we can use that region, that selection recipe, in place of the geometry that we had selected for cyclic 2. Now when we say deselect all, you may not have that on your selection bar. If not, you'll need to go into the selection group and turn it on. But there in the process, I just turned off the selection bar. We'll turn that back on in just a moment. So here for cyclic 2, we'll select our selection recipe of cyclic 2. And here you can see we've got an update pending. I'm going to need to update that before we'll be able to assign selection recipes successfully, because that update is required in order to bring those attributes forward into the FEM. So here you can see we've got regions assigned by faces for our surface-to-surface contact, which we'll need to replace with a selection recipe. We'll create an attribute selection recipe, which will be blade contact, which will be a string, name blade contact, and I think the value was 1. And the preview is not working because we need to update the finite element model. Alright, so let's go back to the assembly FEM, and we can go ahead and update all of our component FEMs to bring those attributes forward into our finite element models. And then let's go ahead and fix our selection recipe for blade contact, because the value I had assigned earlier actually wasn't 3, it was 1. Hit the tab key and you can see those faces are previewed. Alright, so let's go ahead and rename that to blade contact. Next we'll create another selection recipe for our disc contact. Same strategy, attribute, call it disc contact. Look for polygon faces with a user attribute string of disc contact and value of 1 or 3. Let's try 1 first, and we'll turn on the disc there, and looks like maybe it was 3. Or maybe we need to get the right name. There we go, disc contact and 1. Right. Okay. Let's go ahead and give that a better name. We'll call that disc contact. Oh, we can also see that we still have all of the faces selected there. So let's go ahead and turn our selection bar back on so that we can say deselect all and pick our selection recipe disc contact. Alright, so there we have one object in the region selection. Alright, and select contacts shows the faces. Select contents. Alright, very good. So now we can use that to specify our surface-to-surface contact. Now we can't reuse the objects that are in the FEM. We're going to have to create new ones. But before we do that, let's continue on with creating another attribute selection recipe for specifying our fixed constraint. Here this one we called fixed with a value of 1. Hit the tab key and we can preview that face. Let's go ahead and edit our user-defined constraint. And we'll deselect all geometry objects and select our selection recipe. Alright, so now here for our temperature constraint, or our temperature load, we need to select the bodies of the blade and the disc. You can see that those selection recipes exist in the FEM and have been brought forward. However, we need unique ones that are authored in the sim for this to be robust, because there's a chance we may have different or no selection recipes in the FEM for the bodies of the disc and the blade. So here, to ensure that, let's create fresh ones in the sim for both the disc and the blade. Alright, that was blade with a value of, let's see, was it 3? Hit the tab key. No, let's try 1. Well, it looks like 1 or 3 does not work. Let's go back and check to make sure we didn't have a problem when we created the attribute in our master PRT file, the blade stage 3 blade. So let's go ahead and select the solid and edit the properties, and here you can see there's no value assigned to the blade, so let's go ahead and put a value of 1 in there, or 3. Hit the tab key, green check to assign it. I must have missed the green check to assign it before. So now to make sure that that attribute comes forward, we'll go into the FEM, have it update, and then up to the sim. Now if we edit that disc blade 3 selection recipe, you can see that we have that that blade selected. So now we can use that and the disc one to specify our temperature load. So we'll deselect all from our temperature load, and we'll just select the selection recipes that we authored in the sim for the disc and the blade. Alright, so that should do it for the sim. Next, let's go ahead and make sure we've saved everything now that we've updated it. And one last thing that we need to do to the template FEM is we need to deselect or remove all polygon bodies out of that FEM. And go ahead and save it. We'll say save work part only. Alright, then we can go ahead and close everything. And next we'll move those templates, the template FEM and SIM that we just created. So there's our template FEM and our template SIM. Let's go ahead and copy those over to our CAE templates directory, our simulation templates directory, under our installation directory. I'm running NX 2007. You may need administrative privileges in order to write templates into that directory. But once you do, you'll see that there's a Pax file here that we need to edit as well. That file also needs administrative rights to edit, so I'm going to go ahead and copy it over to a location where I don't need administrative rights to edit it, to one of my local directories, and you'll see that it's organized in paragraphs. Each paragraph is one template. So what we can do is copy that paragraph as a guide to create our new FEM and Sim templates. So that was a Simcenter magnet, looks like a Sim template that's English that we just copied. And I copied it twice. And we'll need to increment the D number. The last number was 79 on the magnet template there. We'll make a D80 and a D81. And then we'll give it a name, third stage blade disk template, or just third stage blade disk. And this will be our empty third stage blade disk sim. All right, and then we can create a JPEG if we want for a symbol for what that template's going to look like in NX. And just so I don't mess up typing the name, I'm going to copy the name from that location to the file name location in our Pax file for that Sim template. Here you can see it's English. English is the correct units that I was using when I created that Sim originally. And we'll go ahead and give it a name of third stage. Now for our FEM, I've selected a Sim template that maybe wasn't the best choice. Let's go to an English FEM template and copy that. So I'll remove that D81 that we had before, and we'll paste in this one. This will be our new D81. And then we can use the same names that we had assigned to the Sim above. Except this one we want it to be empty third stage FEM. All right, we'll take the default JPEG thumbnail, and here I'll copy the name so I make sure I get it right. And paste it in. All right, it's English, that's correct. We're not going to say Simcenter magnet, we'll say Simcenter third stage for our filter type. All right, so that looks good. Let's go ahead and save it up. And in order for this template to take effect, we need to restart NX or Simcenter 3D. And we also need to copy that template file that we just created back into our templates directory where NX is installed. All right, now we're ready to fire up NX. And let's go ahead and test out our template. So we'll start by opening up the blade, and we'll create a new FEM. When we create a new part file, here we see all of the templates that we have to select from. And at the bottom, there's our third stage blade disk, FEM template. All right, so I'll go ahead and say OK. We'll select the bodies to use as being just that blade. and it immediately meshes it as soon as you open it up. And all we need to do is turn on the layer that it was meshed on, which was layer 11. That's where we had originally put the layer for our mesh. And there you can see our mesh for our blade. Alright, next we'll go to our disc. Go ahead and open up the disc eye part, where we've already got the disc trimmed up. And we'll create a new FEM using that same third stage blade disc template. I'll go ahead and select the geometry that I want to bring into the FEM. And here you can see it's already got the cyclic CSIS defined as part of the template. So we don't need to define that. It meshes it up automatically for us, assigns physical properties to the mesh. And now we're ready to create our assembly FEM. But to do that, we need to open up our assembly that has our disc and blade in it. It's our compressor assembly. And now I'll create a new assembly FEM. Now here I could have created a new template assembly FEM as well, but there basically wasn't anything in there except for cyclic CSIS, which I can easily define. So here we'll go ahead and map in our stage 3 disc into the assembly FEM. We'll say list only associated models to make sure we are getting the right one. And since we selected original layers, came in on layer 11. And then we'll go ahead and map in our blade. Alright, so now we've got our assembly FEM created. The only step that we could have automated with the template would be the definition of the cyclic axis, which I'll do manually right now. Alright, so that looks good. Let's create our new, let's create a sim using our sim template. But before we do that, let's go ahead and make sure we don't have any label conflicts for the nodes and elements with the assembly label manager. Now we'll select our sim template to create our new simulation using the disc blade sim template. We won't create a new solution because there is a solution already in the sim for our multi-step nonlinear analysis. You can see we have all of our cyclic symmetry boundary conditions, face contact, temperature loads, rotational loads, and constraints already defined based on those selection recipes, and we're ready to solve. And that concludes the demonstration.